Mars, often referred to as the Red Planet, has captivated human imagination for centuries. Its rugged terrain, mysterious history, and potential for future colonization make it a prime target for exploration. The allure of Mars is undeniable, with its vast plains, towering volcanoes, and the possibility that it once harbored life. However, beneath this captivating surface lies formidable and invisible threat, one that could prove to be a significant barrier to human exploration. As space agencies and private companies accelerate their efforts to send human crews to Mars, they face a challenge that is both daunting and unprecedented: the lethal high-energy radiation that constantly bombards the planet, particularly during solar storms. Unlike Earth, which is protected by a strong magnetosphere, Mars lacks this natural shield. Earth's magnetosphere acts as a protective bubble, deflecting harmful solar radiation and cosmic rays that would otherwise bombard the surface. This magnetic field, coupled with Earth's dense atmosphere, ensures that most of this radiation never reaches the ground. In stark contrast, Mars is shrouded in a thin atmosphere that is only about 1% as thick as Earth's. This thin layer of air offers little defense against the onslaught of radiation from space, leaving the planet exposed to high-energy particles like protons, ions, neutrons, and gamma rays. This harsh environment poses a significant risk to any future astronauts who might set foot on Mars. Recognizing this threat, scientists at NASA and the National Oceanic and Atmospheric Administration (NOAA) have been working tirelessly to develop strategies to protect astronauts from this invisible danger. Their primary focus has been on understanding and mitigating the risks posed by solar energetic particles (SEPs), which are intense bursts of radiation emitted by the sun. These particles can strike with little warning, and their effects can be devastating. The challenge for these scientists is twofold. They must devise ways to shield astronauts during their months-long journey to Mars and ensure their safety once they arrive on the planet's surface. The journey from Earth to Mars is fraught with peril. Solar storms, which are caused by eruptions on the sun's surface, can unleash powerful flares that hurl X-rays, gamma rays, and charged particles across the solar system at nearly the speed of light. In May 2024, a particularly strong solar flare demonstrated just how dangerous these storms can be. This flare sent a wave of radiation hurtling toward Mars, arriving in just tens of minutes. Fortunately, NASA's MAVEN spacecraft was in place to observe the event. MAVEN, short for Mars Atmosphere and Volatile Evolution, has been studying the Martian atmosphere since 2014. Its instruments are designed to measure the interactions between solar radiation and the Martian atmosphere, providing scientists with valuable data on the challenges that future astronauts will face. However, MAVEN's capabilities are limited. While it provides crucial information about space weather at Mars, it cannot do the job alone. To expand our understanding of space weather on Mars, NASA has planned to deploy 2 additional spacecraft later this year. These spacecraft, known as the Escape and Plasma Acceleration and Dynamics Explorers, or ESCAPE, are being built by Rocket Lab and operated by the University of California Berkeley's Space Science Laboratory. The ESCAPE mission, which will be launched aboard Blue Origin's New Glenn rocket, aims to enhance our ability to monitor the impacts of incoming energetic particle events on Mars. The 2 spacecraft will work together to provide real-time space weather assessments, much like a weather forecast on Earth, but for a planet millions of miles away. This information is vital for ensuring the safety of astronauts on the Martian surface, as they will need to be able to assess local space weather conditions independently, without relying on delayed communications from Earth. In May 2024, during a significant solar storm, NASA's Curiosity rover, which has been exploring Mars since 2012, captured evidence of charged particles arriving at the Martian surface. The storm produced the largest surge of radiation ever recorded by Curiosity's Radiation Assessment Detector (RAD). This instrument has been diligently collecting data on Mars' radiation environment for over a decade, helping scientists better understand the risks that future human explorers will face. The radiation environment on Mars is a complex mix of galactic cosmic radiation (GCR) and secondary particles generated by interactions in the atmosphere or soil. However, during solar storms, spontaneous SEPs from the sun can dominate the Martian surface radiation field, creating hazardous conditions that could last for hours or even days. Protecting astronauts from this radiation is one of the most significant challenges for Mars exploration. Don Hassler, the principal investigator of the RAD instrument, and his team had been working on various strategies to shield future crews from exposure. During a recent space weather workshop, they discussed the need for advanced warning systems and improved modeling capabilities to predict solar storms and other space weather events. These warning systems are crucial for giving astronauts enough time to take shelter during a solar storm. However, despite the progress made, there are still significant gaps in our ability to predict space weather at Mars in real time. These gaps in prediction capabilities are largely due to a lack of observations from key locations. For instance, there are no current observations from the Sun-Mars Lagrange point 1, a point in space where the gravitational forces between Mars and the Sun balance each other out, allowing a spacecraft to stay in a stable position relative to both. Additionally, we lack observations from the far side of the Sun, which would be essential for predicting solar storms that are headed toward Mars but are not visible from Earth. James Favors, NASA's Space Weather Director, emphasizes the importance of closing these data gaps to improve the accuracy of our models and predictions. Accurate predictions are crucial for protecting astronauts from radiation exposure. One potential solution that NASA is exploring is to equip future Mars missions with Earth-independent space weather capabilities. This approach would involve integrating observational and modeling tools directly into the crew vehicle architecture. By doing so, astronauts could generate actionable space weather predictions without needing to rely on data transmitted from Earth. This capability would be particularly important during times when communication delays with Earth make it impossible to receive timely information. As humanity moves closer to the reality of sending missions to Mars, the importance of protecting astronauts from space radiation cannot be overstated. The risks are very real, and the stakes are incredibly high. But with the dedication and ingenuity of scientists at NASA, NOAA, and other organizations, significant strides are being made to ensure that our journey to Mars is as safe as it is awe-inspiring. Mars continues to beckon with the promise of discovery, adventure, and the next great leap for humanity. But to reach this distant world, we must first overcome the challenges that lie in wait. To journey to Mars is not just about reaching a new frontier, it's about ensuring that we can thrive there, building a sustainable human presence on another planet. With each new breakthrough in our understanding of space, weather, and radiation protection, we move one step closer to making this dream a reality.